Okay, so input and output tables. These are basically a list of numbers that you input, then you do something to the numbers, and you get an output. Sometimes you'll see the input listed on the top and then output underneath, but this is the more normal style here. Where it says function at the top of the little table, that is actually where you are going to write an algebraic formula. It could be x minus 6, could be x plus 2, could be 4x minus a half. We'll see later on how you find out what the correct function is. So in this table, we still don't know the function, but we do know what the input is. They're the numbers under the x. And when we do something to the numbers under x, we will get the y. So if you look at the first row, if x is 1, then y is 3. Next, if x is 2, y is 6. If x is 3, y is 9, and so on. The only difficulty is we don't know exactly what we're going to do, because if you look at the x equals 1, we could be doing x plus 2 equals 3. We could be doing 3 times x is 3. We could be doing 5 times x minus 2 is 3. We're not sure yet. Whatever we do to x has to work no matter if x is 1 or x is 6. The easiest way to do it is pick a nice easy number for x, like the 1, and then look at different choices you have so that you get the correct y output. So with x, the input being 1, we could do x plus 2 equals 3, x times 3 equals 3, x times 2 plus 1 equals 3, and we could go all the way up to something as complicated as x times 6 minus 3 equals 3. What I would do is write down a few fairly easy ones with low multiplying first, and then you go to the next step. When you have a few things written down for the first easy number, go on to another easy number. In this chart, obviously 2 is a nice low number. It's a good one to start with. So use the same formulas. We've got plus 2 times 3 times 2 plus 1 times 6 minus 3. Start with the easy ones. So if we do x plus 2, and we're assuming that x is 2, 2 plus 2 is 4. It's not 3, and 3 is the output we need, so that's automatically no good. If we try our second choice, x times 3, we get 2 times 3 is 6. That's good. We're pretty sure now we've got it. We have a good idea that x times 3 is going to give us the output that we need. If you want to be really careful, you could do every number in the x column, the input column, and double check it. What I'd recommend is after you've done it with a couple easier numbers, it works for both, then pick a number further down the input side and try it out. So what I've done here is I've taken the 6, input is 6, and I got 6 times 3 equals 18. That's also good. So now we know that the formula will work times 3. The formula times 3 will work if with 1, it'll work with 2, and it'll work with 6. So it's probably worth being lazy and saying that's going to be my answer. We've decided that 3 times x equals y. 3 times the input is the output. one thing you want to remember is that 3 times x, or x times 3, should be written as 3x. So the formula we would use for this is y equals 3x. Okay, so if you look at the first line, 3 equals 3 times 1. Then 6 equals 3 times 2. Then 9 equals 3 times 3, and so on. Here's another quick example. We've got inputs of 2, 3, 4, 5, 6, and outputs of -2, -1, 0, 1, 2. Remember, start with a fairly easy number, and 2 at the beginning is a pretty easy number to start with. So think about all the ways you can change 2 from the input into an output of -2. I could do 2 times -1. That gives me the right answer. I can do 2 minus 4 equals -2, the right answer. I could even do 2 times -2 plus 2, and that gives me the correct output of -2 as well. I've done a few different options. I'm going to move on to another number now. Okay, moving on to the next number in my input column, it's a 3. So let's substitute 3 in for the x and see what happens. 3 times -1 is -3. That's not the output we want. We need -2, so it's no good. Let's look at the next formula, which is x minus 4. If we substitute 3 for x, we get 3 minus 4 equals -1. That's good as well. We're pretty close now. We think we know the right answer. When we're pretty sure we have the right number, we'll pick another number from the input column just to make a final check. So this time I chose to use x, the input, equals 5. And we need to get an answer of 1 as the output. So if I substitute it in, x 5 minus 4 equals +1. That's good. That's what I need. I have the answer. And I'm all done. My formula is x minus 4 equals y. Now, in this example, we're going to find that things got a little bit more complicated. We've got the x's being 1, 2, 3, 4, 5, and the outputs, the y, being 0, 3, 6, 9, 12. We're going to start this one the same way as we did the other ones, but we're going to notice that we need to get into a little bit more complicated math to get the right answers all the way through for all of the inputs. If we start with the easy number, 1 for the input, and we put it into the formula x minus 1, 1 minus 1 is 0. Looks good. We can also do multiplying, and 0 times 1 is 0. So those two equations work perfectly for the input getting us the output we want. There are also other options. For example, 2 times x minus 2 gives us 0. 3 times x minus 3 gives us 0. 4 times x minus 4 gives us 0. And we can keep going. So 1,000 times x minus 1,000 also gives us 0. But let's leave it there, and we'll start checking with a different input. Now, if we take the input x being 2, we'll notice the problem with the really easy possibilities very quickly. So if we use x minus 1, we get 2 minus 1 is 1. That's not the output we need, so that's no good. If we do 0 times 2 equals 0, that's also not the output we want, so that's no good. If we do 2 times 2 minus 2, we get 2. That's also no good. But if we do 3 times 2 minus 3, we get 6, and that's what we want, so that's good. This tells us that 3x minus 3 works with at least 2 of our inputs. So we'll do a final check with another number with another input. So at this point you could use an input of 3 or 4 or 5. I just chose 5. So if we take the input being 5, we've got 3 times 5 is 15, minus 3 is 12, and that is good. So now we know the formula 3x minus 3 works for 3 different inputs, gives us the right outputs. So let's just take a risk and say that's good enough, we're done.